Hey everyone, welcome to episode 4 of season 2 of Blender Story course. Right off the bat, let me say this: to get the most out of this episode, make sure you've already watched episode 4 of season 1. That's where we modeled the object we'll be working on today. And don't forget to check out the first 3 episodes of this season as well. They're all interconnected and each one builds on the previous one. So, the object we'll be working on today is the bookshelf. As always, I've included the practice file for this episode in the description and you can download it for free. This file contains the 3D model of the bookshelf that we modeled back in season 1. If for any reason you don't have your own model handy, no worries, just grab this file and follow along with me. One thing to note, the textures folder in this file is empty. Instead, you'll find the text file with a link to the textures we'll be using. To make things easier, I've added the same link in the video description. The textures are hosted in a fantastic website called ambientcg.com, which is a goldmine for free, high-quality assets like textures, materials, and HDRIs. You can use these in your projects for free. If you want to learn more about their licensing, just click on the licensing menu on their website. It's such a generous and valuable resource, and they're offering these assets for free. So, if you're in a position to support them, consider donating to help sustain this incredible community. Now, when you open the link I've shared, you'll see a preview of the material you're about to download. By default, it's in thumbnail mode, but if you prefer, you can switch to 3D preview. Here's a quick tip for navigating their 3D preview mode. Hold the left mouse button to orbit around the material, use the middle mouse button or scroll wheel to zoom in and out, and with the right mouse button, you can pan the view. They've also added some handy tools in this section. For example, you can choose different HDRIs to see how the material reacts under various lighting conditions. Plus, you can select simple meshes from the geometry drop-down menu to better visualize the material. Super cool, right? There is another display mode called Tiling Preview, where you can scroll with the mouse wheel to see how the texture tiles. Now, for downloading, it's quite simple. In this section, on the left side, you can download the images in JPG format, and on the right side, you can get them in PNG format. As you can see, you can also download them in different resolutions. For this episode, I'm using images with 2K resolution and PNG format. To download, just click on the desired option. If you're not familiar with formats and resolutions yet, don't worry, you'll get the hang of it as you go. After downloading, you'll have a zip file that needs to be extracted. Once extracted, go into the folder, cut or copy all the files, and paste them into the textures folder included in the practice files you downloaded. These 2 extra files aren't needed, so you can go ahead and delete them. If you'd like, you can explore the website further, go to the materials section, click on wood here, and choose any wood material you like for this project. Alright, now that we've downloaded the textures, we're ready to get started. Let's move on to the first step, mesh optimization. I'll start by clicking this icon in the geometry section and enabling the wireframe checkbox. This will help us better visualize the geometry of the mesh. As I've mentioned earlier in this course, I've assigned the custom shortcut for this option for easier switching. To do that, you just right-click on the wireframe checkbox, select Assign Shortcut, and type your desired hotkey. Personally, I've assigned Ctrl-W to it. Alright, as you can see, the topology of the mesh we created isn't too dense. The only objects where we can reduce topology a bit are these cylinders, right? So, I'll press Shift-A to add a new cylinder. Over here, I'll click and reduce the vertices to 16. Then, I'll press R, followed by X, and type 90 and hit Enter to rotate it by 90 degrees. Now, I need to place this new cylinder exactly where the old cylinders are, right? So, first I'll hold Shift and click to select these cylinders. I'm going to right-click, go to Set Origin, and choose Origin to Geometry to make sure the origin of each cylinder is perfectly centered. This step is important because I want to move the new cylinder based on the origin of the existing objects. Next, I'll select this new cylinder first, then hold Shift and select one of the old cylinders. I'll press Shift-S and choose Selection to Active. This snaps the origin of the first object I selected to the origin of the last one. Now, I just need to scale the new cylinder to match the old one. But before that, I'll select the new cylinder, press Tab to enter Edit Mode, and activate Face Select Mode by pressing 3 on the top row of the keyboard. Then I'm going to select the cap faces, press X, and delete them by choosing Faces. Next, I'm going to press 3 on the numpad to switch to the right view. Since I'm still in Edit Mode, I'll press A to select all the faces, press S to scale, and adjust it until it matches the old cylinder. Then I'm going to press Alt-Z to enable X-ray mode, press S again, then Y to scale it along the Y-axis as well, and click to confirm. I'll middle-click and drag to return to the perspective view, press Alt-Z to exit X-ray mode, and press Tab to go back to object mode. Here I'll click once more to select the object underneath, and just to make sure I've selected the denser cylinder, I'll press G to grab and move it slightly. Yep, this is the one. I'll click to confirm and then hit delete to remove it. Alright. Do you remember how we used Alt-D for linked duplicates instead of the regular Shift-D duplication when modeling repeating parts like this section of the object? Remember that? If it rings a bell, you'll recall that using linked duplicates kept the meshes connected. This means that if we made changes to the one component, all the duplicates update the same way. Pretty cool, right? Back then, the reason we chose linked duplicates was to save time. If we ever decided to tweak the mesh, those changes would automatically apply to all duplicates, so we wouldn't have to edit each one individually. That's why we used linked duplicates for all the repeating parts of this object. It was a major time saver. But the advantages of linked duplicates don't stop there. Since you've come such a long way in the course, let me show you another incredible benefit of this technique. Take this simple plane as an example. If I activate statistics from here, you see that this mesh is made up of 4 vertices, 4 edges, and 1 face, right? Now, if I go back to object mode and create a regular duplicate using Shift-D, you'll notice something. The number of components in the scene has doubled. We now have 8 vertices, 8 edges, and 2 faces. But watch this. If I delete the duplicate and instead create a linked duplicate using Alt-D, look closely. The number of components in the scene stays exactly the same. It doesn't increase at all. Even if I create multiple linked duplicates, the component count remains the same. I can create as many as I want, and the scene stays just as lightweight as it was before. Wow, that's the real power of linked duplicates. This means our scene remains incredibly optimized and lightweight. So, this is another great reason to use linked duplicates whenever the situation allows. You might be thinking, why not use linked duplicates all the time then? That's a great question. While linked duplicates have this amazing advantage of keeping the scene optimized, they also come with some limitations, which we'll explore later. Alright, let's get back to our scene and continue our work. I'll select this and create a linked duplicate using Alt-D, click to confirm, hold Shift, select this object, then press Shift-S and choose Selection to Active. Now I'll click here again, press G and move it upward. Alright, I'll press Delete to remove it. Next, I'll select these 2 objects and create linked duplicates of them using Alt-D. First, I select this one, then the other, press Shift-S and choose Selection to Active. Then I select this one and then this one, press Shift-S again and choose Selection to Active. Finally, I delete the old cylinders as well. That's it. The other objects already have proper topology, so the first step of our process, optimizing the objects, is done. The only thing left before moving on to UV mapping is to make sure their scale of all objects is correct. This means their scale for every object should be set to 1. If I click on Object Properties, you'll see that in the practice file I provided, the scale for all objects is set to 1, except for these spheres at the top of the legs. See? Their scale isn't right. To fix this, we need to apply their scale. For example, if I select one of these spheres and press Ctrl A to open the Apply menu, then click on a scale, a message pops up saying that because this sphere is linked to other objects in the scene, applying their scale will break the link. Since we don't want to break this connection, I'll cancel it. Instead, I'll select all the objects that are linked, then press Ctrl A and click a scale. You'll notice that the scale for all of them is applied without any warning message, and everything is set to 1. Alright, that's done. Now save your scene, and let's move on to the second step, UV unwrapping. First I select this one, then I move my mouse here to the corner, click and drag to split the viewport into 2 sections. Then I'll click this icon and choose Shader Editor. Wait, why the Shader Editor? Well, before starting the UV unwrapping process, it's usually a good idea to apply a temporary texture to our object. This helps us to ensure the UVs are correct and functioning as they should before we move on to the main material. Does that sound confusing? No worries. Let's do it step by step and it'll make more sense. I'll press N to close the side panel in the shader editor. Next, I'll click the new button at the top to create a material and name it UV texture. Now, I press Shift A, search for image texture, select the node, and place it here with a click. This node might look familiar, right? It's the same one that gets created when you drag an image into the shader editor and loads that image for you. But when you add this node manually using Shift A, it doesn't load any image by default. If you want, you can click Open to load an image from your hard drive. However, we're not going to load an image from our drive. Instead, we'll use an image generated by Blender itself. So, I'll click New, change the generate type to UV grid, ignore the other options, and just click New Image. Now, I'll connect the color output of the image texture node to the base color input of the principal BSDF node. But why can't we see the result on the object? That's because we're currently in solid display mode, whereas we need to switch to either material preview mode or rendered display mode. For now, I'll activate material preview mode, which uses the eevee render engine, and you'll immediately see the result. Alright, as you can see, we assigned the material to this leg. However, since the other legs were created as linked duplicates, any material we assign to one of them will automatically be applied to the rest. This happens by default, but it can be changed. Don't worry about that for now, I'll explain it in detail later. Also, make sure to select this HDRI from here to ensure the lighting in the scene is neutral. This allows us to see the colors more naturally. Now, if you look closely, you'll notice that this texture was generated by Blender. It's usually used to check UVs because it helps us identify whether the texture we're going to use is distorted. Right now, you can see that the UV grid is stretched, which means the UVs for this object are incorrect. Ideally, this grid should look like square checkboxes, not rectangular ones. Now that we've created and assigned this temporary material to our object, it's time to confidently move on to UV unwrapping. So, I'll switch the shader editor to the UV editor and make sure this object is selected. Press Tab to enter edit mode, and immediately, you'll see the UV grid texture appear in the UV editor. Alright, first, I'll activate this option here, Sync Selection, so I can see the entire UV of my object even if all its components aren't selected. Also, any components I select will simultaneously be selected in the UV editor. As you can see, when we added the cube to start modeling the leg, this UV map, which belongs to the cube, was created by default. However, it doesn't match our current object, right? So, we need to work on this. Let's start by marking the seams. Notice that since this UV map was generated by default, you don't need to delete it from the object data properties under UV maps. Even though the object is unwrapped, there are no seams marked on it. Okay, I'll press 3 on the top row of the keyboard to switch to face select mode, select this top face and this bottom face, then press U and choose Mark Seam. Did you see that? There is no need to individually select each edge. Just select the face, mark the seam, and Blender automatically marks the edges forming that face as seams, because seams are only for edges, right? You can't mark a face or a vertex as a seam, can you? Alright, now we also need to mark one of the 4 vertical edges around the leg as a seam, right? This helps the object unwrap and flatten properly. It's better to choose an edge that's less visible, so the seam and any tiling issues in the texture remain hidden. The best choice here is the edge facing inward toward the shells. So I'm going to select it, press U, and mark it as a seam. Next, I'll press A to select all the components, then press U, choose Unwrap, and select Angle Based. And just like that, our object's UV map is unwrapped and packed into the UV grid. And also, the problem with the stretched checkerboard texture is now resolved. This means that if we replace the checkerboard with our own texture later, it will display correctly and proportionally on the object. Fantastic! So now you understand the purpose of the checkerboard texture. Now, if I return to object mode, select another leg, and enter edit mode, you'll notice that the same edges we marked as seams for the first leg are also marked for this one. Why is that? That's right, because these objects were created using linked duplicates. They are linked and they inherit the same UV map and seams from each other. So we've just seen another great advantage of using linked duplicates. What could be better than this? What problems could possibly exist that would make you not want to use linked duplicates all the time? Don't rush, we'll get to that. For now, if you think you can guess what issue might arise, leave a comment to see if your guess is correct. As you can see, the seam is currently facing outward. So we need to rotate this leg so that the seam facing inward, right? To do this, remember how I mentioned that all transformations should be done in object mode to avoid affecting the linked duplicates? So I'll switch back to object mode, press R for rotation, then Z to constrain the rotation to the Z-axis, type -90 and hit enter. Now if I switch to edit mode, you see that the seam is now facing inward. Great! Back to object mode. Now let's move on to the other legs. I select this one, and as you can see, it seems is also facing outward. I'll make sure I'm in object mode, press R, then Z, type -180 and hit enter. To double check, I'll switch to edit mode, and yep, the seam is now facing inward. Now we need to fix the rotation of this leg as well. Again, in object mode, I'll press R, then Z, type 90 and hit enter. Switching to edit mode confirms that the seam is currently facing inward. Perfect. That's it for UV unwrapping the legs. Now, let's move on to the shelves. First, I'll select one of the legs and click on the Material Properties tab. And as you can see, whichever leg I select has the same material assigned to it. So, I'll click and drag this icon onto the shelf object to assign the material. And immediately, you'll notice that the texture scale isn't correct. Alright, I'm going to select the shelf object, press the / key on the numpad to isolate it, and press tab to enter edit mode. I select this face, then press 2 on the number row to activate edge select mode, hold shift, and add these edges to my selection. Next, I'm going to press U and choose Mark Seam. Now I'll press A to select all the components, then U, and choose Unwrap followed by Angle Based. And that's it. This is the UV unwrap for the shelf object. Next, I'm going to press / again to exit local view. And since these shelves were also created as linked duplicates, you see that the seams for all of them are correctly placed and they've been unwrapped properly. Alright, now I'm going to click and drag this UV grid material onto this object. Press tab to enter edit mode. Select this edge, press U, and choose Mark Seam. Then I'll press A, U, unwrap, and select Angle Based again. Okay. You'll notice that the UVs of the other linked objects were also unwrapped correctly. Next, I'll click and drag this material onto the sphere. For these spheres, the default UV is fine for now. UV unwrapping a sphere can be done in different ways depending on the situation. For now, the only thing we can do to improve it is to go to edit mode, select all components with A, then press S followed by Y to scale it along the Y axis. This adjustment will make the UV grid texture appear more square-shaped. Keep in mind that if you look at the sphere from the bottom or top, the texture will still look distorted. This is due to the way the UVs are unwrapped and the placement of the seams. But don't worry about this for now. Later, I'll show you how to handle objects like these. And that wraps up the UV unwrapping for the bookshelf object. Now it's time for the final step, creating a wood material for the bookshelf using the textures we downloaded. Okay, let's start by switching this panel to the shader editor by clicking on this icon. We'll begin with the shelf object. First, click on a slot 1 and remove it by clicking the minus button. Then click on the new button to create a new slot with a new material. Next, navigate to the folder where we stored the texture images. Although you could select all of them at once and drag them into the shader editor, let's start with the image that has color at the end of its file name for easier explanation. So I'll click and drag it into the shader editor, and you'll see that an image texture node is created, loading our image. Now, it's super simple. Just connect the color output to the base color input of the principled BSDF shader. Instantly, you'll see the texture applied to the object. If you zoom in, you'll notice the nice details on the surface. However, there's an issue. It looks too flat. So let's move on to the other textures to see what they bring to the table. The next image is the one with roughness at the end of its name. If you take a look, you'll notice it's essentially the same as the color image, but in black and white. Alright, drag this image into the shader editor as well. As the name suggests, it should connect to the roughness input, right? If you remember, the roughness slider in the principled BSDF shader defines how shiny or matte the material is. The closer the value is to 0, the shinier it gets, and the closer to 1, the rougher it becomes. But what happens if we let this black and white image control the roughness instead of a single value? Let's test it out. Connect the color output of the roughness texture to the roughness input of the shader. Immediately, the roughness slider disappears, and this image takes over. If you look at the material on the object now, you see that each part of the texture has a different level of roughness. To better visualize the effect, switch the viewport shading mode to rendered display from this section. This will give you a more accurate view of how it looks. Keep in mind that since the render engine is set to eevee in the render properties, what you're seeing in the rendered display mode is the eevee rendering result. Because eevee is faster, we'll leave the render engine as eevee for now. As I navigate through the viewport, you'll notice that the roughness is no longer uniform, and the result looks much better. But there's still a problem. The wood material looks greasy when it should appear rougher. To fix this, since the roughness texture is a black and white image, we need to make a small adjustment to the image texture node reading this texture. Simply, from here, just change the color space to non-color. Since this is a grayscale image and not a colored one, Blender needs to treat it as black and white. For the color texture, the color space is set to sRGB, which is correct because it's a colored image. But for black and white images like roughness map, the color space should be non-color. If you're unfamiliar with concepts like color space and sRGB, don't worry about it for now. Just remember this simple rule. When importing colored images, the color space should be sRGB. And when importing grayscale images, the color space should be non-color. Stick to this rule for now, and you'll avoid most issues. Now, after changing the color space to non-color, notice how much more realistic the wood material looks. The roughness map is doing its job perfectly. Now, let me give you a simple and basic explanation of how roughness works and affect the material. If you've been paying attention, you'll notice that many properties in shaders and nodes change with numbers. When we change these numbers, we're essentially changing the properties, right? Now, in black and white images, pure black represents the number 0 and pure white represents the number 1. Any shade of gray that exists between black and white will have a value between 0 and 1. For example, neutral gray has a value of 0.5. When we use a black and white image, the roughness or any property will interpret black as 0 and white as 1. So, if we import an image that has a gradient from white to black, the roughness value will change depending on the color of the pixels in the image. Isn't that cool? So, black and white images define different values across the surface of the object. For example, if you have the Node Wrangler add-on activated and you hold Shift and Control while clicking on the image texture node for the roughness texture, you see that the connection between the principal BSDF shader and the surface gets disconnected. And instead, the color output of the roughness texture is connected to the surface, allowing you to directly see the roughness texture applied to the object surface. You'll notice that there is no pure black anywhere in this texture. So there is no spot where the material would look shiny, and instead, the texture consists of various shades of gray. Alright, now I'm going to hold Ctrl Shift again and click on the principal BSDF to reconnect it to the surface so we can see the materials effect again. So far, you've seen that color property or color maps only define the color for the materials, and there is no other data in it except color. Roughness is solely responsible for determining how rough different parts of the material should be. Now let's move on to the next texture, which has a bit of a strange appearance. Normal map. As you can see, we have two types of normal maps here, normal DX and normal GL. For now, you don't need to worry about the difference between them. We're working with a normal map that ends with GL. Just note that different software packages may perform calculations differently. So for some, it's better to use normal GL, where GL is short for OpenGL, and for others, it's better to use normal DX, where DX stands for DirectX. Blender, by default, does the calculations for this map based on OpenGL, so you can simply import this normal map into the shader editor and leave the other one out. Now, you might think, okay, we can easily connect the color output of this map to the normal input of the principal BSDF shader. But let me tell you that to connect this map correctly, we need an intermediary node that will convert this texture data into normal data so that we can use this map properly. And the name of this intermediary node is simply normal map. So I press Shift A, type normal, and drop it onto this connection. As you can see, Blender is smart enough to automatically connect the inputs and outputs correctly. The color goes to the color input of the normal map node, and the normal output of the normal map node goes to the normal input of the principal BSDF node. Now again, you might not notice any significant changes yet. That's because for normal map textures, you need to always change the color space to non-color. And as soon as you do that, you'll be able to see the amazing effect of the normal map. You can see the incredible level of detail it adds to our material. All these little details, like bumps, indentations, and protrusions, are all created by normal map without needing to model these details in the geometry. It's a highly useful, important, and impactful texture map. Okay, if you want, you can easily adjust the strength of this effect by tweaking the strength property in this node to make it stronger or weaker, and leave it at the default value of 1 for now. Folks, as we go on, we'll get to know more details about these maps. For now, don't worry too much about them. But to better understand these texture maps, of which you've only encountered 3 so far, the color map, roughness map, and normal map, I highly recommend checking out the very beautiful and practical Adobe Start 3D collection. I've placed the link in the description for you. I can't emphasize enough how important it is for all 3D artists, especially beginners, to watch this collection. It's vital. Alright, now let's see how we can change the color of this wood to make it look a bit more stylized and less realistic. To do this, we can use a very useful node called Color Ramp. So I press Shift A, search for Color Ramp, select it, and place it onto this connection. As you can see, the connection between the input and output is automatically done, and immediately the image is converted to black and white. In fact, we can say it removes the color, and now we can apply our desired colors to the image based on the dark and light areas of the texture. For example, if we click on this and then click here to open the color picker, we can select a color like this, and this color will be applied to the darker parts of the image. Then, if I select this one, which affects the lighter pixels of the image, and choose a color like this, the light pixel will turn to this color. To better understand, imagine that our texture is this gradient that goes from dark to light. Now, if in the color ramp, I change the color of the dark parts of the texture to a different color, let's say a blue like this, you can see that now the gradient goes from blue to white instead of black to white. Now, for example, we can change this white part to another color, like green, and now the gradient goes from blue to green. Isn't that cool? Now, if you drag these color spots and bring them closer together, you'll notice that the color transition contrast becomes more pronounced, and the gradient change turns into a sharper one. Pretty awesome. So, I'm clicking and dragging these closer together to increase the contrast between these colors and making the wood grains a bit more noticeable. Now, for a better view, I'm going to assign this material to the other parts of the bookshelf as well. Alright? Now, I'll come over here and try different HDRIs to see how the material looks under different lighting conditions. As you can see, for example, this HDRI has a really nice effect. And since we're planning to work with a warm lighting for this room, and the lighting I have in mind is closer to this HDRI, it could be a good option. If you'd like, you can also rotate the HDRI image by changing its rotation to check how the light angles affect your object in the same lighting setup. On the other hand, for a better result, you can go to the render properties and activate ray tracing to get a more natural result in the eevee render engine. Alright. Now, I'll also increase the strength of the normal map a bit and set it to 2 so that the details show up better. That's done. Now, if you've noticed, we haven't used the mapping node yet, and we won't be able to change the scale of the texture if we want to, right? So, for this, if you remember, all we need to do is select the image node, press Ctrl-T, which is the shortcut that works when the Node Wrangler add-on is active, and these two nodes will be added. Now we just need to connect the vector of the mapping node to the vector of the other image texture nodes, so that if we want to apply any transformation, it will be applied to all the textures simultaneously, right? Because these textures are exactly the same and only their data differs. However, for now, I'm not going to adjust the scale or location of the texture. I think everything is fine as it is. I've just set these up so that when needed, we can easily tweak them. Alright, now to make the result even better, let's increase the bevel on the shelf edges a bit more to make the edges softer and improve how they react to the light. So, I'm going to adjust the rotation of the HDRI here so the light hits the edges, allowing us to better observe how the edges react to the light. Now I'm going to select all the shelves, go to the modifier properties, and to change the bevel amount for all 3 objects at once, I'm going to hold Alt, and to make the changes slower, I'll also hold Shift with Alt and adjust the amount to soften the edges just a little bit. Alright, as you can see, it now shows more reaction to the light. You can better notice its effect by turning the bevel on and off. Usually, for stylized objects, we can exaggerate the bevel amount a bit to enhance that cartoonish feel. Alright, now, you can see that up to this point, it's looking pretty cool. However, there's a major issue, and that is, for example, if we look at the texture of this shelf, you can see that the textures are simply copied and there's no variation between the textures of these shelves. And this is exactly the issue that link duplicates can cause. Of course, for the other parts of this bookshelf, like the legs or these spherical sections, since their distances from each other are quite large, the texture repetition isn't as noticeable. But for these shelves, it's quite noticeable. That said, it's worth mentioning that usually different objects like books, decorations, and other things can be placed on this bookshelf, which can make the texture repetition less noticeable. But it's good to know that if we want to get rid of this repetitive pattern, here's what we should do. Alright, it's time to explore linked data in Blender and see exactly what happens when we duplicate using Alt-D. If you've noticed, when you add a mesh in Blender, if you look at the outliner, you'll see an orange triangle-shaped icon for the object we added, which indicates that the object type is a mesh. Next to it, there is another triangle-shaped icon that represents object data. And if you click the small arrow and open the mesh, you'll see that the object data is actually a child of the mesh, right? When you duplicate this object normally with Shift-D, another object is added in the outliner, and .001 is added to the name of the object. And you can't remove this suffix because you can't have two objects with the same name in the scene. The same goes for object data. For example, if I try to name the object data the same, Blender won't let me. Now, if I press Alt-D to create a linked duplicate, and then check the outliner, you see that the object data of these two objects now have the same name. And if I change the name of one of their object data, you'll see that the object data name of the other object changes to the same name. This means that the object data of these two objects is linked, so they share a lot in common. Now, if I add another mesh like this monkey or Suzanne and click on its object data icon in the outliner, it will take us to the object data properties. Here at the top, you can see the name of the object data, which is currently Suzanne, right? You can also change its name here, for example, to monkey, and you see that the name of the object data in the outliner changes to monkey as well. If I click here, we can see a list of all the object data in the scene, and we can choose which mesh use which object data. For example, if I select this object data, you'll immediately see that the monkey mesh changes into the cube mesh. Even though the object's name is still Suzanne, what's displayed is actually the object data, which is currently the cube we've selected for it. So, since all these objects share the same object data, they are linked. So, everything is based on the object data, and the object itself is a type of container that doesn't display anything on its own. The object data determines what the mesh should be. Alright, now, when we assign a material to one of these linked objects, by default, the material is actually assigned to the object data. Since all these objects share the same object data, the material will be applied to all of them. So in the outliner, you can see that this material is actually a child of the shared object data. However, since this cube has a different object data, this material isn't assigned to it. Alright, let's say I change the material's color to blue. Now the question arises, how can we assign different materials to linked objects while keeping them linked? The answer is simple. Instead of assigning the material to the object data, we assign it directly to the object or mesh, which, as we said, is a container. Alright, how do we do that? Just select the object among the linked ones that you want to have a different material, and in the material properties, if you click here, you'll notice that the material is assigned at the data level, so this means it's linked across all the objects. To change this, switch to the object level by clicking on this icon, and now you can assign a unique material specifically to that object. Notice that at the data level, everything stays as it is. We've just moved one level up to the object level to override the material. Now, if you click New to create a new material, you'll see that this new material in the outliner is no longer a child of the object data, but a child of the object. Now we can change its color, and the link between the objects is still intact. Now, if you collapse these linked objects in the outliner by clicking on the small arrow, you see that there is a small difference between them. In front of the objects, the icons you see are the child of the objects. For these two objects, their child are only the object data, but for this object, there are two child. One is the object data, and the other is the material we assigned at the object level. Of course, it might be a little confusing if you're encountering this concept for the first time, but don't worry. Just like many other things, it will make sense over time. I just recommend that you watch this part one more time to make sure it's clear. Now, to solve the texture repetition problem on the shelves, all we needed was to learn this. So, let's see how we can use what we've learned. Since these shelves are linked, if you go to the object data properties, you see that the UV maps section is included in the object data. This means that UV maps are part of the object data. Since all of these shelves share the same object data, their UV maps are the same. So if you want to change the UV of one of them, to use a different part of the texture, all of them will shift together. So we should assign the material we created to them at the object level. So I'm going to select this middle shelf, go to the material properties, and here you'll see the number 4 next to this material. This means that this material is applied to 4 objects in the scene, which is correct because our bookshelf is actually made up of 4 parts, and the rest are just link duplicates of these 4 parts, right? So I'm going to select this middle shelf and go to the object level, and you'll see that at the object level, there is no material assigned yet. So I click here and select the material that we created. Alright, you see that it's been added, and now in front of this part, the number 5 appears, which means that this material is used in 5 places. 4 places we saw in the data level, and now once here in the object level. This means that if we change this material, the changes will reflect in all 5 places where it's used, because this is actually just one material and it's used in 5 different spots. Now, if we want to make a duplicate of it and separate it, we can click on this number and a duplicate will be created. Now you see that there is no number next to it, meaning this material is no longer used on any object other than the one we selected. Also, a suffix has been added to the material's name. I'm going to change this suffix to object level so you don't get confused. Now if we change this material, it won't affect the others. Perfect. So now we can easily go to the shader editor and in the mapping node, change the texture location slightly. Simple as that. Now, let's do the same for the bottom shelf to make sure we've got the hang of it. So, I'm going to click on this icon to go to the object level, click here, select material, click on this number 5 to duplicate it and break the link with others, change its name if you'd like, and finally, very simply, change the texture location here. For example, this time, I'm going to shift the texture on both the X and Y axis. Alright, that's it folks. We've finally reached the end of episode 4. This was a very important episode, so please make sure you understand the concepts in this episode, and if needed, watch it again and don't forget to practice with it. Thanks for staying with me this far, and I hope you enjoyed this episode too. Until the next episode, take care.